Well, hello everyone. I wanted to create a new segment to help everyone who is at home, weather enthusiasts, and also for some of the teachers and students. A little background that some of you know, some of you don't know. I've actually been teaching meteorology classes at Penn State Altoona. Gosh, I think I started in 2003. So I do have a college course that I give, and the nice thing is I get to a lot of times talk to students when they're in the young elementary days and then they take it as a class. One thing that they notice is meteorology can be complicated, but I'm going to keep it pretty simple. At times I'm going to have experiments. At times I'm going to just have presentations like this. And I'm going to let you know right now, because I've got so much going on my screen, I'm not going to be able to address questions until the very end of this. But hopefully you enjoy this, and I'm going to talk about identifying clouds. And I thought I would start off a little bit in talking about what a cloud is, and seeing what a cloud is. The basic way of me describing what clouds are is to think about fog. You've been in a cloud. Fog is a cloud that forms on the ground, and then the difference between, whoa, I have to make an adjustment here, so hang with me, everyone, as I notice that my screen is not the appropriate size yet. So I will bear with me as I make the appropriate change. I should be able to do this. Let me go ahead and I apologize for a second. First segment always is going to have some issues with it, but I will be able to persevere through this. There we go. Getting there. We're getting there. Just give me one more movement, and you guys get to see the behind the scenes of me making these adjustments. There we go. First day jitters. How about that? All right. Well, the difference between fog and the clouds is where they're located. To get clouds, we need some sort of lift. So the way we get fog is we have air drops to the dew point temperature, and we get condensation into little tiny droplets of water. And same thing happens. We lift air, we get them up into the sky, it cools to the dew point temperature, and we get some fog. So let me go ahead now, and we're going to take a look at the classification of clouds, and that's what today's conversation is about. Cloud classification actually came up from a chemist who his name was Luke Howard. He was a pharmacist and a chemist. He came up with the system of identifying clouds back in 1803, and he used Latin names. Medicine, science, back then that was very common, and it was based on appearance and the altitude of the clouds. So it is based off of appearance, altitude, and then whether it's precipitating or not. We added that a little bit down the road. Layer clouds are flat clouds. They're described as stratus, and that is a Latin origin that means kind of like a blanket. It is much wider than they are tall. They have flat bottoms. They have flat tops and often can extend from a horizon to horizon, and it indicates relatively stable air. And what that means is the air, there's not a lot of up and down movement in the air. If there is a lot of up and down movement, we get what's called convective clouds. And these have a Latin origin too. They have the root word cumulo, sometimes before, sometimes afterwards, and that is a Latin term meaning heap. And they form in this unstable air where the air is going up and down. They're as tall or even taller than they are wide, and they have a more lumpy look to them. So those are two main ways. And then we add in the altitude descriptions. The root word cirro, which means curl, describes high clouds that are composed of wispy ice crystals alto, and you remember alto maybe in the music world, is described as a cloud in the middle of the troposphere. And all of our weather happens in the bottom layer of the atmosphere, troposphere. And I may actually go into the layers of atmosphere in a different one of these. All right, precipitating clouds. So we talked about the stratus and the cumulo, and now we're going to say whether they precipitate or not. And we used the root word nimbus, either before or after, prefix or suffix, describing a precipitating cloud. Now, let's go down and we're going to break down the types of clouds for you. Low clouds. A very common low cloud, and a lot of us are having it right now, stratus clouds. They're fuzzy, they're featureless clouds that are light to dark gray in color. They cover the sky, and basically it's like this fog that's in the air. And for the most part, as I'm looking out my window, I'm seeing that. And here is a picture of stratus clouds. Pretty much that blanket of gray clouds overhead. And there's one where stratus clouds are low enough that you're getting, technically it's a cloud, but it's also fog, because the cloud layer is right close to where the mountain layer is. So when you're on the surface and the cloud's touching the surface, that would technically be fog. All right, so we have stratus. Now let's talk about stratocumulus. Strato, stable, cumulus, unstable. That means the air is starting to get a combination of both clouds. And what happens is we start to get this intermixture of white to gray, or sometimes blue to gray. So here is a stratocumulus deck, and it's flat on the bottom, flat on the top for the most part, starting to get a little bit, but in places the clouds have gotten thin enough that you're seeing the sky. And this is a lot of times associated with fronts in large-scale systems. And what happens is we start to heat the ground. This is an interesting one. So we start to heat the ground starts heating air, and the air starts moving up and down. So in some places the clouds got so thin we're seeing blue sky. So what happens is we're taking a stable area of clouds and we're making it unstable, and that's what stratocumulus clouds are. And sometimes you won't have clear spots in between, but sometimes you will have bright spots. So it's still kind of a stratus deck, but you're starting to get the bright spots. And where there's brighter clouds, here's an interesting thing. Clouds are white, first of all, because they reflect all colors of light equally. And all light together equals white. It's the opposite of coloring. You mix different colors together and you get a different color, and you put enough colors together, it becomes black. Well, light works the other way. All the colors of the spectrum, all the colors of a rainbow, another topic that I'll cover, Roy G. Biv, we'll talk about that name down the road in another segment. That white is all the colors being reflected all together. Now, a lack of light is black. So where you're seeing the light spots in these clouds, you are seeing, let's see if I can highlight this for you, where you're seeing these, whoops, maybe not, where you're seeing these light spots in the clouds, we are, here we go. All right, where you see the light spots, that's where the clouds are thinner. Where you see the dark spots, that's where the clouds are thicker. And you're starting to get that stratus layer where there's some ups and downs, and in places the clouds are thicker than other spots. All right, so we also have cumulus clouds, which have well-defined low flat bottoms and then contoured heapy kind of tops to them. And let me go ahead and give you an example of these low clouds. And that is here. See how the bottoms are kind of flat and then you have a little heaping on the top of it? These are known as fair weather cumulus. They don't have much to them, and usually the weather's pretty nice with them. They're just those puffy clouds. You may start off on a clear day, and what this is a sign of is the atmosphere is starting to become unstable. We're starting to get lift, and this could be the first sign of showers developing, but right now it is just it could be also pretty nice weather. If they get deep enough, they start to get a little precipitation underneath it. And this is the one difference between the stratus rule. You'll start to get some building on it. That's known as cumulus congestus. And here's even more. Not quite a thunderstorm, but we're starting to get a lot of development. And this is the early stages of a thunderstorm. Now, we're going to take the stratus and the cumulus and the stratocumulus. We're going to just make it into mid-level clouds. So, low-level clouds are closer to the atmosphere. I mean, closer to the ground. They're in the atmosphere, obviously. Closer to the ground. Now, alto clouds are middle clouds, so they're a little bit higher, but they have the same thing to them. So we throw that alto term in with it. And alto stratus clouds are layered clouds up of mostly liquid water droplets because they're still pretty low in the sky. And they're a lot of times gray to pale blue in color, and at times you can see the sun through them. So the sun's being filtered through the clouds right now. And there's another alto stratus. Another type of mid-level cloud is alto cumulus. They're same as stratocumulus, but with a higher base up in the sky. And there you go. And there is a great rule of thumb that we have to distinguish the difference between cumulus, alto cumulus, and cirrocumulus that we'll get to in a little bit. So a cumulus cloud is a big puffy cloud. Alto cumulus, if you notice, the puffiness seems a lot smaller because they're farther away. Something in a distance will appear smaller. So how can you tell the difference between a cumulus cloud and an alto cumulus cloud? Well, hold your hand out. Let me get all the way back here. Hold your hand all the way out, and there we go. If you look at the clouds and the cloud is bigger than your fist, that is a cumulus cloud. If it's smaller than your fist, put your fist in front of the cloud, but bigger than your thumb, then that's an alto cumulus cloud. And so it's a little bit farther away, so they're smaller in size. Now, if we go even higher, and we go higher up, and it's bigger than your fist, smaller than your fist and smaller than your thumb, then it's really far away, and they're cirrocumulus clouds. And they're like these ripples in the sky. And often what you can get out of this is this like almost fish scale look to the sky. They're just really far cumulus clouds, the same as the close ones, but they're just so far away. And they can resemble fish scales, which goes to the old weather saying, mackerel sky, not 3 days dry, because a lot of times these will precede a precipitation ahead of a warm front. We get warm air moving in aloft, and we start to get instability up high in the atmosphere. So a lot of times these are before storm systems. Does it work every time? No, but long ago that's what they had for forecasting the weather. And then we have sometimes patches of cirrocumulus really high in the sky. Other high clouds. So we talked about cirrocumulus. We also have cirrostratus. They can be thin or thick, white or gray in appearance, and there's a deck of thick cirrostratus, so it's really high in the sky. Really high up there. And then we have, sometimes they're thin, that you can see the sun through them. And at times we get halos. And then interesting, this can happen around the sun. It can happen around the moon. Sometimes it's pretty bright, and you can even during the daylight hours see a separation of colors with these halos. An interesting thing about halos, and it happened while we were on our Go With Joe cruise. A lot of people, I don't know why, but each time it happens, a lot of people will sit there and go, I've never seen something like this before, but it happens all the time. Well, I'm talking about at least a half dozen, a dozen times a year. It's just you may not catch it up in the sky. And they used to say a halo around the sun or a moon means a storm is coming, because again, these are the first clouds that move in before a storm system. Sometimes the clouds are so, and I'll cover things like halos and rainbows in another 101 coming up down the road. Sometimes the halo's so faint, but you have a halo that goes up this way and one that comes out around this way. It's hard to draw three-dimensionally, and you'll get what's called a sundog, and it's kind of a fake sun. Sometimes it has color like this, and you'll get one often on either side of the sun at equidistance, and it's the same angle as if you would have had that halo. And then another type of high cloud is cirrus clouds. They're thin, wispy, fibrous clouds, and sometimes they call them mare's tails because it looks like a horse's tail, maybe upside down. And again, pretty fair weather. So far we've covered based off of altitude, where you have the low clouds, then you have the alto clouds, and then you have the cirro clouds. We talked about cumuloclouds, which are unstable, how lumpy, up and down to this, and stratus clouds, which are pretty flat. Now let's go to, I guess, the fun clouds, and this is precipitating clouds. Now this isn't quite as fun. We had this earlier in the day for today. Nimbostratus clouds. They're deep clouds. They can bring precipitation. They can be dark gray to pale blue in color, and it gives you precipitation. And in my college class, I always show this picture. And, you know, there is an interesting thing. So how can you tell the difference between this and a stratus cloud? You know, how can you figure out the difference? Because, you know, a stratus cloud and nimbostratus look the same. The difference is right there, the puddles. And you could, that's how you could tell if the rain's coming down or not. It's just whether it's precipitating or not. And here is a nimbostratus situation where rain's coming down, and often as the precipitation falls from the clouds, it evaporates, it saturates the air, and you'll also have a fog that it extends down underneath the cirrostratus. And then we have the cumulonimbus clouds. Thunderstorm clouds often have a flat anvil shape to the top of the clouds. There's a picture of a cumulonimbus off in the distance, and there's an anvil. So what happens is it extends through the whole troposphere, and that's where we have up and down, but the stratosphere is very stable. That's why jets love to fly there. And it hits that stratosphere, which is like a lid to the atmosphere, so as the moisture in the air rises from the thunderstorm, it spreads out, and that's what gives you an anvil. So let me go ahead and show you a better picture here where the anvil extends out. Now once in a while you'll have an overshooting top. Now and what happens is the air pokes into the stratosphere briefly and comes back. My best example of how to get that overshooting top is, imagine we have a beach ball and we swim it to the bottom of a pool. And I always joke with my college students, I'm like, I'd like to see you try to swim a beach ball to the bottom of the pool because it has a lot of buoyancy. And it's very hard to swim a beach ball to the bottom of a deep end of the pool. But if you let go, it rises. It's got so much buoyancy. It's got so much momentum. A lot of times it'll rise above the water and then come back down and float. And that's what this overshooting top is. The beach ball is going up, shoots up, and comes back down, and then just fills in with the anvil. So those are cumulonimbus clouds. And down the road, I'm going to have some thunderstorm and some lightning safety tips, and we'll talk more about severe weather depending on how long we're going to be stuck in this situation with a lot of us at home. And I know a lot of teachers will appreciate some of this stuff. I know clouds aren't some people love clouds. I will tell you, I had an intern. She was a cloud fanatic, and she's now a meteorologist in charge of a National Weather Service out in Montana. She loved clouds. She would talk about them forever. Some people are not quite as interesting, but it would be nice to help describe some things that are in the sky. Now, something that happens here and doesn't happen in a lot of spots are these. They're lenticular clouds. And it's interesting, and you're going to be, no, it doesn't happen. Yes, it does happen. When people see these, sometimes they're like, we'll get UFO reports, and yes, I do get phone calls and Facebook messages. They're like, oh, there's an object out there I can't understand. And what this is a lens-shaped cloud, and it usually happens over ridges. So let me show you what happens. So you take this dry air, and there's a level of moist air, and when the air hits the mountain, it lifts, and it lifts just enough that we get condensation into droplets, and we get this cloud that forms over it. and you'll get that lens-like cloud. Now, sometimes you'll be like, oh, I saw one away from mountains. What happens is it lifts, and think about this. Here's another thing to think about. Think about a slinky. You ever take a slinky and pull it and let go? It'll bounce, right? So what happens with these lenticular clouds is we lift the air over the mountain, we go down, and there's like this up and down bouncing that happens. And on the up part, you may have what we call Lee wave clouds, and they make some nice wave clouds that show up on satellites, sometimes through a whole state afterwards. And those are lenticular clouds. And again, you need something like a mountain. These are not the best places to fly because in these up and downs, it can really mess with airlines. So if you see lenticular clouds and pilots see that, they usually try to avoid that area. Now, another one that I'll cover is contrails. Now, this one, I know because I'm on the internet, I'm going to have some people who will contact me, and these are not. This contrail stands for condensation trail. And what it is the water vapor is one of the outputs of a jet engine. And what happens is, think about on a damp, cool day like today, you walk outside, you see that cloud forming out of your mouth. Well, your dew point temperature of your breath is higher than the temperature of the air. So the air coming out of your mouth is a dew point temperature. It reaches a dew point temperature and forms a cloud, but then the dry air evaporates it away, so that cloud doesn't last forever. And if you notice on these contrails, and again, condensation trails across the sky from the jet, you'll have it form right behind the jet, and it'll slowly dissipate on the other side of the sky. Now, I know some of the people sit there, well, I see it spraying on out. There are people who actually think there are things being dumped out of the planes, or yes, I even heard this one, dumping their toilets out on the, this is not anything but a condensation. And some people say, well, sometimes it really spreads out afterwards. Well, if the winds are stronger up high and the atmosphere is really moist, you'll have this spread out into a wider cloud. And contrails are harmless, and what you can take from the contrail is when you start to see contrails after a deep blue clear sky, that means the atmosphere high up where the jets are flying are moist enough. It's starting to get damp enough that water vapor is forming into clouds. And here is a nice little chart that you can use. And this will be on wearecentralpa.com afterwards, and it's a chart of all the clouds. So you have the low clouds, the stratus, flat layered clouds, stratocumulus with some up and down cumulus clouds, and have some nimbostratus and some. Then we'll get to the altocumulus, alto stratus, cirrostratus, cirrus clouds, and cirrocumulus really high in the sky, and then you'll have the thunderstorm cumulonimbus clouds way high in the sky. All right, so I want to thank you guys for all tuning in on this. Hopefully you learned something. Now, if you have any questions about this, I see some of the questions there. I'll answer some. And if you have a suggestion, go ahead and send me a message. Hey, Joe, can you cover this topic? And maybe I will. So let me get to some of these. And hello to everyone. So Carmela wants to know, why do we see contrails on some days and one jet and not another on the same day and a different jet? Well, remember, Carmela, that it's part of an atmosphere that's moistening up. So one jet may be flying here and another jet may be flying here, and it may be dry here and moist here, or vice versa. So that's sometimes, so the atmosphere is just barely enough to give you that contrail. So let me see if I have any other questions on this. And again, hopefully you enjoyed this. And well, that's all I have for right now. All right, well, I will post this on wearecentralpa.com. I hope you guys have a great day, and I will see you on tonight on WTAJ News at 5 to 6:30, and tonight on WTAJ News at 11. And again, if you have any suggestions about a topic in the future, go ahead and send me a message or put a post here, and I'll think about doing a Weather 101 on that too. All right. Have a good day.